I'm Taylor Fomer, and I'd like to thank you all for coming in today on a Saturday to help judge our presentations. And my topic today is storm surges and effects of sediment deposit. And my first question for you guys is, have you ever been involved in a hurricane or ever been in one, like in a location where there has been one?
Thank goodness no.
Hurricane Katrina 1996.
I have as well, and this is why I chose this topic, because today I will be looking at Hurricane Katrina and the effects of it that occurred in Louisiana. Now, this first slide is a picture of the track Hurricane Katrina followed, and as you can see, it affected this area mostly. As we all know, New Orleans is one of the most common areas that we all look at today. And my topic is just about how the sediment was affected. Now, researchers Faulkner, Plumlee, and McQuinn all looked at this area and wanted to see how not only the man-made destruction, like what happened to the man-made objects, but the natural surroundings. So they just took samples from this region. And another researcher that I did not add into my presentation today was Eric Ockboats. And what he looked at was a Category 5 hurricane versus a Category 3. Now, a Category 3 hurricane can actually cause more flooding and almost as much damage as a Category 5. And as you can see, the Category 3 color is red, and when it reached landfall in this area, it was a Category 3. And this is why New Orleans suffered from so much flooding as well. These pictures were the after effect of Hurricane Katrina. This is the obvious flooding in New Orleans, and the houses are barely above water. This picture is from Hackberry Chenier Beach, was a region Faulkner looked at. You can see the houses were moved and even destroyed. This picture shows that sediment was moved after Hurricane Katrina hit. This photo was taken in New Orleans, and it's a car buried under sand, and this is a proven fact that sediment was added to the region. Method number 1, Faulkner. Faulkner noticed a sediment change in Hackberry Chenier Beach located in Louisiana. And what he did was he planted plots on the front edges of the sand dunes in this region and then dug them up and took samples from the layers of each plot. He did this because he wanted to see how the sediment was buried and how much sediment was added after Hurricane Katrina hit. Not only did he do this, but he also looked at the healthiness of trees. The trees were highly affected in this area after Hurricane Katrina hit in 2005. So, because of this, he looked at the soil and the trees itself to see the differences that occurred. Method number 2, Plumlee in 2005. Now, Plumlee located his research in New Orleans in 3 different areas. He located it in the marshlands, the downtown New Orleans, and the lakes near New Orleans. Not only did he study the sediment in these areas, but he also studied the chemicals that were originally there and the new chemicals that were there. He also looked at the pyrite mixtures and the iron mixtures. He also had to take a notice of the debris in this area. And then this picture shows the flooding levels of each area. This is downtown New Orleans. As you can see, it was highly affected and was 8 to 10 feet. The next researcher is McQuinn, and his study was more previous than the others. And he studied the Mississippi Delta and how it was affected. He noticed that the sediment wasn't being deposited as fast enough for the vegetation in this area. And this is a picture that shows, this is before New Orleans, where the marshlands are very healthy and were growing. This is after, where they were deteriorated. So he took the 3 layers of the delta and studied them into 3 different zones. Results from Faulkner. After Faulkner used a sieve, which is a wire metalling technique, to separate the coarse samples to the finer samples. So his study showed that east to west, the gradient sediment increased from 74 inches to 3 inches. These sediment changes were obvious to the scientist. When he looked at the sediment changes, it changed from, the mixture was sand, silt, and clay, and after the Hurricane Katrina hit, the sand went to 100% when it was evenly mixtured. He noticed from the trees, the dense forests, that they were toppled over, the leaves were falling off, so it was an obvious change that the soil was messed with, and that the tree's healthiness would not go back for a while, and studies were still being taken after this project because they still didn't know how to look at the trees correctly. Results 2, Plumley, 2005. The 3 different areas that were studied in New Orleans all were very different but had quite similarities. New Orleans downtown actually had a more similarity to the New Orleans marshland. This is because pyrite was seen in both these areas. However, the pyrite concentration levels were higher in the New Orleans marshlands. They also looked at New Orleans downtown and how the debris affected it and made a concentration metal higher than any other area. This picture is an example of the pyrite sample. Results number 3. All 3 zones were highly affected and very different, which proves that something went wrong in the sediment deposition in the Mississippi Delta, because the sediment used to be all in the same with past studies. Zone 1 showed it was a light gray and had a very sandy texture. Zone 2 is a gray and is very buff sand. It was very fine, not coarse at all. While Zone 3 was a muddy brown with a light touch of red and was very muddy. Implications and conclusions. So they took data from the past to help with their studies to compare these and see the differences in between their results. But the thing is, during this time period, they had different technologies before the data was taken. So what if the data from the past was incorrect? An article that I read said that beach nourishment would help the beaches. But by this, it only says the sand is what's helping the beaches, and by adding sand, this is what beach nourishment is. But how is beach nourishment beneficial? Because you're just adding more sand on top of more sand. And another question I had after reading these articles was, did this only occur with Hurricane Katrina? The only articles I found that were affected with sediment was Hurricane Katrina. Other areas were not. So the scientists said in their articles that further research in different areas would have to be taken in order to know that this happens with every hurricane and not only one. Conclusion. Hurricane Katrina not only affected the natural surroundings, but in Louisiana. We must have more precaution for Category 3 hurricanes because the damage that it caused in New Orleans is highly affectable, and we don't look at them too dangerous because they're not Category 5s. Another thing that researchers looked at was the climate change, and this affected it because the climate can change with hurricanes, and it was noticed that the climate could change, which caused the high intensity of Hurricane Katrina. And that is all for my presentation today.
Could you explain when in the beginning we were talking about the methods, the scientist planted plots?
Yes.
What did he mean by that? I was trying to figure out what he meant by that.
He took the areas on the sand dunes and made a hole in that region, and he dug them up. And the one picture, if I can,
I may not come back up because
I don't. Well, there's a picture.
Yes. Little dome thingy in the middle.
That's what I meant about plots. He dug them up and on the front edges, so he could see the differences. And because the sand dunes were so high versus when they were, that's why he did that.
What was the idea behind pyrite? Was it pyrite versus other iron, like oxides?
Yes, because the region was already filled with iron and natural medical mixtures. The levels of pyrite, they were shown before Hurricane Katrina hit, but they were highly elevated after. So they wanted to see how the difference was affected.
I'm just trying to figure out, so where does the pyrite come from? Is that coming off the bottom?
That's what the researchers didn't exactly say. That's why they believe that the hurricane brought it in, and the debris caused more pyrite to be shown after the hurricane hit.
Okay, I'm wondering if it was, if you take pyrite and you oxidize it, you're going to get iron oxides. And so I'm wondering if it was like dug up from someplace deeper.
I believe, after I read, that the pyrite was lifted because of how much sediment was added and how much sediment was taken away after, and the amount of debris. I think it was added to the area, because of the hurricane and how much iron was destroyed and how much trees and natural surroundings were destroyed as well.
Anything?
I understand.
All right, thank you very much.